Here is another random variable. The variable in question is household income for 2014 in the United States. Now, we don't have any numbers provided along the horizontal axis, but if we could see them, they would be representing household incomes from very low income over here to very high income over here. And we do have some information here. We have the 10th percentile marked. So that just means that 10% of Americans make less than $12,300. That was in 2014 too. And I wasn't able to locate a similar graph that was more up to date, so sorry about that. The 50th percentile, which means the median household income, was $53,700, and that blue line shows that. So 50% of Americans make less than $53,000, and 50% of Americans make more than that, and some Americans make way more than that. And then we also have the 90th and 95th percentiles. So we're going to use this graph to answer a bunch of questions on your worksheet. So now we're on page 2 of your worksheet. And what is the probability? Find the following probability using the graph from the US Census. X is the household income in dollars. Answer with a decimal. So the probability that X is lower than $12,300 is 0.10, because 10% of people make less than that. 90% of people make more than that. And again, if you're bad at this, hopefully you'll start getting better at it. X is less than, X is greater than. Now we're back to less than. What is the probability of a household earning less than $157,500? That one's going to be 90%. 90% of Americans make less than that. Ooh, now we're getting a little trickier. What is the probability of a household income between this mark? Let me switch colors here. Between this mark and this mark. 40%. So 50% of Americans are over here. 10% of Americans are over here. So that leaves only 40% of Americans in between these two income levels. And then between 157.5 and 206, that should be 5%, because there's 90% less than this, and there's 95% less than this, so that means there's 5% right here. And there is going to be 5% higher than 206,000. And finally, what is the likelihood of landing on exactly $206,600? Well, what I'm going to show you is that the probability of a single value is always 0 in a continuous probability distribution. Let me see if I wrote that on my solutions. Looks like I did not, but that would be a good thing to know, and I think I have that a little further down. That's what this is. The probability of a single value of X, instead of a range of values, will always be 0, because there's no area associated with it. So what is the area underneath this line? It's too thin. There's no shaded area. Whereas for the previous question, for letter F, we could just shade this area and say, okay, that's going to be 5% of US households. Sorry about that. Okay, so x is a continuous random variable, and this graph gives its probability distribution. This is actually the normal distribution, and I had more slides in the presentation, so I think I'm going to flip over to that next, and then I'll come back here after looking at those. This slide says probability density function. It's the same as a probability distribution. It's just a slightly different way of referring to it, but sometimes we call them PDFs. It's just this smooth curve instead of the histogram that we were sort of used to looking at.